Hello everyone, we're doing a worksheet on congruency and similarity. This is for grade 8th only and does not include the formulas a1 over a2 equals l1 over l2 whole square for similar figures, or the volume 1 or the mass 1. So we're sticking to the grade 8 content. Alright, starting with question number 1, which says the diagram is made up of 5 congruent triangles. Now congruent triangle would mean that if this angle is 42, then this is also 42, this is also 42. All these kites are congruent, so all values are the same. Similarly, if this is y, then this is also y, then this is also y, y and y, and then the this is x, so this is also x, this is also x, this is also x, and so on. Similarly, since the diagram is made of 5 congruent kites. For kites we also need to know that if this angle is y, then this angle is also y, because kite has one line of symmetry, vertical line of symmetry. So we have other angles of size y as well. This is also y, this is y. So all these purple angles are y because of congruency and because of the fact that these shapes are kites. Alright, so first we need the value of x. This is x. We need the value of x. So for that, what I'll do is, in the center I have 1 2 3 4 5 angles, and all 5 angles should sum up to 360. So I can write 5x equals 360 for part A. So x equals 360 over 5, which will give me 360 over 5, which will give me 72. So x equals 72. Next I have to find the angle y. So for angle y, let me consider one of these kites. So this angle is x, which is 72. I haven't drawn an accurate kite. This let me draw a tilted one so that it makes more sense to you. This is 72. These two angles at the top and bottom are angle y, and the lower angle in red is 42. Now this a kite is a quadrilateral, and for a quadrilateral we know sum of all angles equals 360. So what I'll do 360 minus 42 minus 72 and divide the answer with 2. I get 123. So this is question number 1. Next up is question number 2, in which the diagram shows two straight lines AE and BD intersecting at C. Angle ABC. So this angle ABC equals to angle EDC. So these two angles are equal. Sorry, it wasn't angle, it's triangle. So these two triangles are congruent. Write down two properties of line segment AB and DE. Alright, since these two triangles are congruent, we have to write two properties of these. So the first property will be these two are parallel. AB is parallel to DE, and the second property is AB equals DE. These are the two properties. Now I understand that these should be equal since they're congruent, so this side will be equals to this side. But why are they parallel? How do we know that these two lengths are parallel? We know that triangle ABC is congruent to triangle EDC, which means angle B should be equals to angle D. since they're congruent. This is the property for congruent shapes. So angle B and angle D are congruent, and notice this is making a Z, and these two angles are equal. When we're getting alternate angles, that means these two lines are parallel. So that's why these are parallel and equal. Alright, question number 3. The two triangles are congruent. Write down the values of x. Now x is opposite to 9.69 length. So which angle is opposite to 9.69? That's 74. So x equals 74 degree. And then where is y in this question? Alright, here is y. Y is the angle between 74, length between 74 and 46. So where is the length between 46 and 74? That is 8.69. So y equals 8.69 centimeters. Question number 4, which is write down the letters of all triangles which are part A congruent to the shaded triangle. So congruent means exactly identical. So how many triangles are exactly identical to the shaded triangle? This length is 2 units and this length is 4 units. So we're looking for more triangles with such a length. This, I actually can't find any. I think there's G, 2 and 4. Do we have any other? No, this is 2, 3, this is longer, this is 2 and 4. Yes, 2 and 4 units. So we have, I believe, G and E only for part A. Part B is similar but not congruent. Now what are similar triangles? Similar triangles are, so let's suppose a similar triangle to this triangle will be, if I'm multiplying this with 3, this will become 6, then this should also get multiplied with 3 and become 12. Similarly, if I'm multiplying one side with half, this becomes 1, then I need to multiply this with half as well, and this should become 2. So the lengths should be proportional. If one length is being multiplied with a number to get the other length, the second length and the third length should also be multiplied with the same number to get the other lengths. Alright, so how many triangles are similar to this but not congruent? So we can't include G and E, although these are also similar in the context that if I multiply each side with 1, I get these triangles. So this is 2 again and this is 4. So I'm looking for more triangles. Let's try this one. Here this length is 1 and this length is 2. So yes, it is similar to it because both the lengths are being multiplied with half. So answer for this is A. Let's try other lengths. This is 3 and this is 1, 2, 3, 4, 5. So can I multiply these two with the same number to get these? I can't. Let's try, this was F. F did not work. Let's try this one. H has 2 units here and 3 units here. So can I multiply this with a number to get these? No. When I multiply 2 with 1, I get 4. Here I should have had 4, not 3. But that would have made this congruent, not similar. So even H is not included. Let's try some more lengths. So let's try this one. This has 4 units here. And how many units here? 1, 2, 3, 4, 5, 6, 7, 8, 8. So yes, this is similar to it because when I multiply this with 2, I get both the lengths with 2, I get this length B. So B is the answer. And let's try D. This is 1, 2, 3, 4, 5. 5 units here, 1, 2, 3, 4, 5, and there we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 units here. Can I multiply this with a single number to get these lengths? No, I doubt it. And then we have 3 here and 1, 2, 3, 4, 5, 6, 7. Can I multiply 2 and 4 with a number to give me 3 and 7? No, I can't. So I guess A, E, and A, B are the answers for part A and B. Alright, now let's start the questions related to similarity in the worksheet. Question number 1 for similarity, which is the triangle ABC is similar to triangle PQR. Okay, so the question here is find PQ. So let's find PQ. So for similar triangle, we need to know that if ABC is similar to PQR, then AB over PQ equals BC over QR equals AC over PR. So now let's see which lengths we have and which we don't. We have AB, which is 5.2. We have PQ, we need PQ equals, we have BC, we don't have BC, and we don't have QR, so let's ignore this. Equals to AC is 12.4 over PR is 21.7. Now simply cross multiply this. 5.2 times 21.7 over 12.4 equals PQ. 5.2 times 21.7 over 12.4. This gives me 9.1 as answer for question 1. Question number 2. Okay, question 2. Triangle CBA and CED are similar. AB is parallel to DF. AB equals 9, one length is 4.8, then 6, and then K. Work out the value of K. So since CBA is similar to CED, we'll again use the ratios. CB over CE equals BA over ED equals CA over CD. So CB, length CB is 6 plus 4.8, so 10.8 over CE is 6 equals BA is 9 and ED is K. So simply cross multiply and this should give us the answer. 9 times 6 over 10.8. So let's check. 9 times 6 divided by 10.8, which is 5. Then we have question number 3. Triangle ABC is similar to DEF. So again, ABC is similar to DEF. Make the ratios. AB over DE equals BC over EF equals AC over DF. So AB is 8, DE is 6 equals BC is 10 over EF is X, and AC is Y, and DF is 9. So we need values of X and Y. So solve this to get X and then solve this to get Y. So X would be 60 by 8, which is 7.5, and Y would be 8 times 9 over 6. 8 times 9 over 6, which is 12. So 7.5 and 12 is answer for question 3. Question 4, which is Diagram shows two jugs that are mathematically similar. Find the value of x. So simply we'll do 15 over 25 equals 7.2 over x. Cross multiply this yourself and get the answer. Question 5. The answers are at the end of the worksheet. Question 5 is, again we have to find the value of d. So again 20 over 10 equals 9 over d. So cross multiply and you would get the value of d. Next up is question number 5, which is, we simply, I think we just did question number 5. Okay, next up is question 6. So question 6 is, in the diagram AB and CD are parallel, AD and BC intersect at right angle at point X. Okay, so we're given certain lengths, use similar triangles to find dx. So this triangle is similar to this triangle. How do we know that? Because when two triangles are similar, all their angles are equal. So this angle is alternate to this angle because of these parallel lines, and we're getting a z here. So these two angles are equal, and also this angle is alternate to this angle, right? So these two triangles are similar. And how do we express that? We write triangle x CD. So from X I've gone to the blue side, then to the red side. So it's similar to triangle X blue side then red side, XBA. So these two triangles XCD and XBA are similar. So now I'll make the ratios XC over XB equals CD over BA equals XD over XA. So XC is over XB, XC we don't know, XB is 6 equals CD is 5, BA is 10, and then XD we don't know, and XA is 8. So use similar triangles to find dx. So use these to find dx simply. So XD would be 5 times 8 over 10. 5 times 8 over 10, which gives us 4. Yes, XD equals 4. In part 2, calculate angle XAB. So which angle is that? X to A to B. So we need this angle. So we have a right angle here. So if this is the angle we need to find, then this is perpendicular, and the side opposite to the right angle is hypotenuse. So let's use sine theta. Sine theta is equals to perpendicular over hypotenuse. Theta will be sine inverse, where perpendicular is 6 and hypotenuse is 8. So sine inverse 6 over 8, enter this in your calculators. Shift sine 6 by 10, which gives us 36.86. So this is a question from trigonometry. 68.86. So angles are always rounded off to 1 dp. So 68.9. Sorry, 36.9. Alright, for question number 7, I won't go into much detail. Calculate PQ. So we'll need this length PQ. So I'll write, this is question 7. PQ over 19.5 equals 11 over 16.5. I've taken ratios of the corresponding sides, and this should give me PQ equals 11 times 9.5 over 16.5, which is 6.3333. So 6.33 in 3 significant figures. Okay, I entered some wrong value in my calculator. Instead of 9.5, I wrote 19.5. Sorry, instead of 19.5, I wrote 9.5 by mistake. So the answer here is 13. Okay, part 2, calculate BC. Again, to find this length BC, what I can do is, I have PQ, which is 13 now. So I can apply Pythagoras theorem and find QR first. So QR would be, I'm directly applying the Pythagoras theorem, 13 square minus 11 square. C square is equals to A square plus B square. I've simplified it. So again, there's a question, this question overlaps with trigonometry. So I get 13 square, wait, minus 11 square, which gives me 48. So I'll write QR equals under root 48. I won't use the decimal value so that I don't end up doing some early rounding. Alright, so now I need BC, so I'll write BC over QR. QR came out to be under root 48 equals, which lengths do I know, 11 over 16.5, or you could have also used 13 and 19.5. So BC will be 11 into under root 48 divided by 16.5. So 4.61 is the answer. Okay, I've made another mistake here. It should be BC over under root 48. This was under root, this came out to be under root 48. Okay, BC over under root 48 and then 16.5 over 11, not the other way around. So equals 16.5 over 11. Now let's see what do we get. 16.5 times under root 48 divided by 11. This gives us 10.4 rounded off answer. And in the last part we need the angle ABC. So where is angle ABC? This, if this is the angle, the side opposite to the required angle is perpendicular. The side opposite to the right angle is always hypotenuse. So we'll use sine theta. Sine theta equals perpendicular over hypotenuse. So theta equals sine inverse. Perpendicular is 16.5. Hypotenuse is 19.5. So in our calculators we'll enter shift sine 16.5 divided by 19.5, which gives us 57.8 rounded off answer. 57.8 degrees. Angles are supposed to be rounded off to one decimal place. Okay, next up is question number 8. These triangles are similar. Show this equation. So if there's similar, then x plus 3 over the corresponding length x is equals to 2x plus 5 over its corresponding length in the other shape is x plus 4. Cross multiply and you will get, and simplify, and you should get this equation. I hope there's no need to do it. Okay, so do it yourself and you will get the required equation. Question number 9, which overlaps with the topic volumes and surface area. So let's see question 9, part A1, which says calculate the curved surface area of the cone, and we're also given the formula pi RL for that. So pi will simply be pi, r will be 9 over 2, which is 4.5, and L is the slant height, which is 10. So this will give us, in my calculator I'll enter 45 pi, 45 pi, shift, okay, yes, 45 pi. This gives me 141.37, and I guess we're supposed to round it off to one significant figure, three significant figures, so I'll write 141 as my final answer. Okay, next up is part 2, calculate the height of vertical height of the cone. So I'll be using Pythagoras theorem. This is height, this is 10, this is 4.5. So applying Pythagoras theorem, 10 square equals 8 square plus 4.5 square, making h the subject, under root of this equals h. So 10 square minus 4.5 square under root gives me 8.93 as the rounded off answer for height. Yes, 8.93. Okay. Next step is part B. Sasha cuts off the top of the cone, making a similar cone with diameter 3 meters. So these two cones are now similar. uh, Calculate the vertical height of the smaller cone. So it's a pretty easy question. We've already found this height. This was 8.93. If we're taking the rounded off values over, we need the height of this. So over h equals to, we have the diameter of the upper shape over diameter of the lower shape. Cross multiply 8.93. I already have the unrounded off value of this flashing in my calculator, so I'll use that. Answer times 3 divided by 9, and I get 2.976. So 2.98 is the final rounded off answer, correct to 3 significant figures. Alright, question number 10. Hopefully, the last question of this worksheet. Okay, question 10. Okay, Sydney draws the triangle OP1P2. OP1 is 3 blah blah blah. Show OP2. So we simply have to apply Pythagoras theorem, which is C square, which in this case is OP2 square, equals A square plus B square, which becomes 10. So OP2 is under root 10, and we've shown that. Okay, part B. Sydney now draws lines P2, P3 and OP3. Triangle OP3 is mathematically similar to the first triangle. Write down the length P2, P3 in this form, and write where A and B are integers. Alright, so we need the length of P2 and P3. So this is the P2 and P3, and remember these two triangles are similar. So P2 P3 over what is its corresponding length in the previous triangle, that is 1, equals I have this length of the new triangle, which is also the same length of the previous triangle, so under root 10 over the corresponding length in the previous triangle is this, so over 3. So we're taking the ratios of the corresponding lengths, so we get P2 P3 equals under root 10 over 3. So we have our answer for the next part. So this was B1. Next up is B2. So for that, calculate the length OP3, giving your answer in the form of C by D. So where is OP3? Okay, this length. So now we need OP3. So that we will take Pythagoras theorem. So under root, what was OP2? OP2, wait, let me write it down. OP2 came out to be under root 10, and P2 P3 came out to be under root 10 over 3. So we'll apply Pythagoras theorem on these two. So we'll get under root 10 whole square, A square, plus B square, under root 10 over 3 whole square. So I'll just directly enter this in the calculator, and let's see what do I get. So I'm entering under root, then another under root 10 square, plus another under root 10 divided by 5 whole square. Let's see, what do I get? Okay, this is giving me a very weird answer, probably because I'm missing some symbols in the calculator, probably the brackets or something. So let me try to simplify this. This becomes 10, and this becomes 10 by 9. So this becomes 100 over 9 under root, so which gives us 10 by 3. So yes, this is the correct answer, 10 by 3 for part 2. Alright, part C is Sydney continues to add mathematically similar triangles to his drawing. Oh, Sydney is a guy. Alright. Find the length OP5. Okay, so in part C, I have to find the length OP5. Okay, so let's see which lengths do I have by now. I've recently I found OP3, which was which came out to be 10 by 3, I believe. Let me use another color. So I'm going to enter all the lengths that I know so far. Alright, for this part, let me try to draw all these triangles separately. So first I have a triangle 3, 1. Next I have a triangle with lengths under root 10 and under root 10 over 3. Right? Next I have a triangle with sides 10 by 3 and I don't know the lower length, and then I have a fourth triangle whose lengths are I don't know, and I need this hypotenuse in the end. This is OP3, so I need the value of OP3. Also I know that this is also under root 10. So yeah, I have a yellow under root 10 and a red under root 10. Similarly, I have 10 by 3 on the yellow triangle and 10 by 3 on the green triangle. So since these are similar triangles, right? So notice how are we going from this hypotenuse to this hypotenuse. From under root 10, how am I going to 10 by 3? By multiplying under root 10 over 3. Under root 10 times under root 10 makes, no, in fact, let's ignore this. Let's see how am I going from 3 to under root 10. Yes, alright. How am I going from 3 to under root 10? So I have 3, and what do I multiply with it to get under root 10? So I multiply with it under root 10 over 3, so that 3 and 3 get cancelled and I get under root 10. Then from under root 10, so I've multiplied under root 10 over 3 over here. Then again notice how are we going from under root 10 to 10 by 3. So we have under root 10 over here. How is that changing into 10 by 3? So from under root 10, how are we going to 10 by 3? By again multiplying under root 10 over 3. So since the under root 10 times under root 10 makes 10 and 10 over 3. So since these are similar triangles, so all lengths will be proportional. Right? So if the vertical lengths are being multiplied by 10 by 3, under root 10 by 3 to get the next vertical length, then these hypotenuse or the largest sides will also get multiplied by under root 10. So first largest side was, so let's look at the largest side on the yellow triangle, that is 10 by 3. So multiply that with under root 10 by 3 to get the largest side of the green triangle, and from here we'll again have to multiply it with another 8 over 3, under root 10 over 3 to get to OP3. This is a relatively trickier question. So let's see what do I get. In my calculator I'll enter this 10 by 3, wait, fraction key on, 10 by 3 times fraction key on under root 10 by 3 times fraction key on another under root 10 by 3, which gives us 3.70 rounded off answer, which is OP3. So let me quickly revise what I did. It's a mess. Let's see how I can manage that. So from 3 we got to under root 10 by multiplying 3 with under root 3. Now since these are all similar triangles, every length will get multiplied with under root 3 to get the next proportion, to get to the next length. So this is being multiplied with under root 10 over 3 to give us 10 over 3, then this will get multiplied with under root 10 over 3, and then this will get multiplied with under root 10 over 3 to get this one. So we from here we've multiplied under root 10 over 3 once and twice, so that we get OP3. Alright, part D is show that P1 OP2, where is P1 OP2, is this. So we need to simply find this angle. So if this is the intended angle, then the side opposite to it becomes perpendicular, and the side between both the angles becomes base. So we will be using tan theta. Tan theta equals 1 over 3. So theta equals tan inverse 1 over 3. What do we get? Tan inverse 1 by 3, which gives us 18.4. Yes, correct to 1 decimal place. This was part D. Part D2. Okay, write down the size of P2O P3. Now since these are similar triangles, the corresponding angles in similar triangles are the same, so we should get the same value for OP3, which will be 18.4. So same answer for this, it will be 18.4. Since this is 18.4, this will also be 18.4, because in similar triangles corresponding angles are identical. Then the last triangle Sydney can draw without covering his first triangle is OPN minus 1 n. Calculate the value of n. Alright, so what will be this last triangle? What will be this value of n? We started from, in fact, what will be this value of n? We started from P1, then P2, then P3, and so on, and we know this one angle is 18.4, right? Exact 18.4 or what? No, 18.43494. So that value is still flashing in my calculator. What I'll do, I'll divide it with 360. I know the whole circle will be 360, so 360 over answer in my calculator will be 360 divided by answer will be 19.5. So I can fix 19 whole triangles here. So this will be P. Alright, so 19 triangles will fit in this whole circle. So this one here is P19. Keep that in mind, because we started from P1. This is P19, which makes this P20. So the value for n is 20. N equals 20. And we're done with our worksheet. Thank God. Take care. See you guys next time.